Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, October-November 2021, paper 42. Let's start it. Question 1. This question is about states of matter. Complete the table using text and crosses to describe the properties of gases, liquids, and solid. In the first column, particles are touching. This is correct only for liquid and solid, but it's wrong for gases where particles are far apart. Second column, particles have random movement. This is correct in case of gas and liquids, but it's wrong in case of solid because particles of solid only vibrate in its position. The third column, particles are regularly arranged. This is only correct in case of solid, but it's wrong in case of gas and liquid. Substance can change state. Boiling and evaporation are two ways in which a liquid changes into a gas. Describe two differences between boiling and evaporation. The first difference, evaporation happens at any temperature, but boiling happens at a specific temperature, which is the boiling point of this liquid. Second difference, evaporation happens only at the surface, but boiling happens through the whole liquid. Also, we have a third difference, that boiling involves formation of bubbling, but in case of evaporation, there is no bubbles. Name the change of state when a gas becomes a liquid. A gas condenses to form a liquid, so the process is condensation. A solid becomes a gas in a process called sublimation. Question C. Substance boil at temperature X and melt at temperature Y. Complete the graph to show the change in temperature over time as the substance cools down from temperature A until temperature B. It's a cooling curve, so it starts here with a gas, then it will condense to form a liquid. This part you have to go down until reach temperature Y, which is the freezing point of this liquid. Then we will have another horizontal part where the temperature stays the same until all the liquid convert into solid. This part represents solid, again going down until reach temperature B. Question D. Solution is a mixture of solute and solvent. Name the process when solid substance mixed with a solvent to form solution. Solid dissolve in a solvent to solve solution, so the process is dissolving. Name the type of reaction when two solutions react to form insoluble substance. This insoluble substance is precipitated, so the process is precipitation. Question 2. Acids are important laboratory chemicals. Some acids completely dissociate in water to form ions. State the term applied to acid completely dissociate in water. They are strong acids. Complete the equation to show complete dissociation of sulfuric acid in water. Complete dissociation means all hydrogen in the acid convert into protons. So here we have 2 hydrogen. You must write 2 hydrogen as 2H plus, 2 protons, and 1 sulfate with the negative charge. State the color of methyl orange in sulfuric acid. Methyl orange have red color in all acids. Question B. The equation for reaction between powdered zinc carbonate and dilute nitric acid is shown. Complete the equation by adding state symbols. All carbonates are insoluble except sodium and potassium carbonate, so zinc carbonate is solid. We have to write S here. Nitric acid is aqueous. Then zinc nitrate, all nitrate salts are soluble, so here we will write aqueous. Water is a liquid and carbon dioxide is a gas. A student found that 2.5 grams of zinc carbonate required 20 centimeter cube of dilute nitric acid to react completely. Calculate the concentration of dilute nitric acid using the following steps. First, calculate the mass of 1 mole of zinc carbonate. Mass of 1 mole is the molar mass of zinc carbonate, so we will add all the masses together. First, mass of zinc, then carbon, then the 3 oxygens to have 125 grams. This is the molar mass of zinc carbonate. Then, number of moles of zinc carbonate. we will find number of moles by dividing mass by the molar mass, 2.5 grams divided by 125. So number of moles of zinc carbonate will be 0.02. Then number of moles of nitric acid. We will return back to the equation. The ratio of number of moles of zinc carbonate to nitric acid is 1 to 2. So number of moles of nitric acid is double that of zinc carbonate. As the ratio is 1 to 2, so we will multiply number of moles of zinc carbonate by 2, and number of moles of nitric acid will be 0.04. Then to calculate the concentration of nitric acid, number of moles equal to concentration multiplied by volume in decimeter cube. So we will divide the volume of nitric acid, which is 20 centimeter cube, by 1000 to get it in decimeter cube. Then from this equation we will get the concentration 0.04 dividing the volume, it will be 2 mole per decimeter cube. Question 3. Atoms contain protons, neutrons, and electrons. Complete the table to show relative mass and relative charge of proton, neutron, and an electron. The relative mass of proton is 1 and neutron is 1. The charge of the proton is +1, the charge of neutron 0, and charge of electron is -1. Table shows number of protons, neutrons, and electrons in some atoms and ions. Complete the table. First one, sulfur 16, 32. This number 16 represents number of protons, so number of proton will be 16, and number of electrons will be also 16. And to find the number of neutrons, we will subtract 32 minus 16. This will be 16. The second one is potassium. Potassium here has positive charge, means it is a positive ion formed by losing only one electron. So here number of protons will be 19, and take care the number of electrons will be 18. And to find the number of neutrons, we will subtract 39 minus 19. It will be 20. The third one, it is written for you that it has 35 as a number of protons. So you have to go to the periodic table to find the element which has 35 as a proton number, because the proton number is specific for each element. You will find this, the element is bromine. Then we will go to the number of electrons. It's 36. This means one more electron means it's a negative ion, so you will add a negative charge here. To know the mass number, we will add 35 plus 44 to get the mass number, which is 79. Take care here that step for bromine, or the column for concerning bromine, is for 3 marks. Question 4. Chlorine reacts with carbon monoxide to produce phosphogen gas. A catalyst is used. This reaction is reversible, where chlorine reacts with carbon monoxide to form phosphogen gas. The reaction is exothermic. Explain why the reaction is exothermic in terms of energy change of bond making and bond breaking. Here we have to say in terms of the energy of the bond breaking and bond making. So the reaction is exothermic because the energy released from bond making is greater than the energy taken in bond breaking. Question B. Complete the energy level diagram for this reaction. On the diagram, you have to show the product of the reaction. Here it's exothermic reaction, so the product has to be at lower energy level than the reactant. So we will go down here to draw the product at lower energy level. Then you have to show an arrow represent the energy change labeled delta H. Delta H, an arrow going down to represent that this energy is released. The difference, delta H, is the difference in energy of the product minus the energy of the reactant. Third, an arrow represents the activation energy labeled A. Arrow going upward represent the energy taken in as the activation energy. State why catalyst is used in this reaction. We are using catalyst to increase the rate of reaction. Question C. Describe and explain the effect, if any, on the position of equilibrium when the pressure is increased. We'll go back again here. For the reaction, number of molecules on the right side, or number of moles on the right side, is 1, and in the left side, number of moles is 2. So here, if the pressure increases, equilibrium will be shifted to the right side toward the forward reaction because it has fewer number of gas molecules on the right side. If the temperature increased, the equilibrium will be shifted to the left side, will be shifted backward because the right side is exothermic. Giving energy to exothermic reaction means it will be shifted backward to absorb this energy and to oppose my change. So as the forward reaction is exothermic, the increase in temperature will shift the equilibrium toward the left hand side. Question D. The reaction between chlorine and carbon monoxide can be represented by this equation as shown. When 1 mole of chlorine reacts with 1 mole of carbon monoxide, 230 kilojoules of energy is released. The bond energies are shown in this table. Use the information to calculate the energy of the bond between carbon and oxygen in the carbon monoxide. He gave you the total energy released from this reaction, 230 kilojoules. So this is the delta H, and it has to take a negative sign. So this will be minus 230. Okay. First, we have to calculate bond energy in making bonds. In making bonds of the products, we have 2 carbon-chlorine bonds. So 2 multiplied by 400 plus 1 C double bond O, it will be 745. So the total will be 1545 kilojoules. This is for bond making of the product. Then in the reactant we have only chlorine, which is 240. So we will write the equation here. Minus 230 will equal 240 plus the bond energy in carbon monoxide minus the energy needed for bond making, which is 1545. By solving this equation, we will find the bond energy in carbon monoxide 1075 kilojoule per mole. Question E. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosgene, showing the outer electrons only. Here, these circles are already drawn for you. You will calculate the number of electrons, number of outer electrons. In case of oxygen, we have 6 electrons, and it is forming double bond with carbon, so we have to write 2 electrons shared between oxygen and carbon. Then for chlorine is in group 7, so it has 7 outer electrons. It only make single bond with carbon, so 1 electron shared between chlorine and carbon. In each of the chlorines we will have 1 single bond. So here this question is for 3 marks. 1 mark will be for the single bond between chlorine and oxygen, chlorine and carbon, and the second one will be for the double bond between the carbon and oxygen, and the third mark will be for the outer electrons, the 2 lone pairs of oxygen and the 6 outer electrons of chlorine. Question 5. Iron is a transition element. Potassium is in group 1 element. Iron and potassium have the same type of bonding. Name and describe the type of bonding in these 2 elements. The bond, of course, is a metallic bond. The description of the metallic bond. Metallic bond is a lattice of positive ions arranged in rows, surrounded by a sea of delocalized electrons, and it is held together by electrostatic forces of attraction between the positive ions and the negative electrons. This question is for 4 marks. 1 will be for the name of the bond, metallic bond. The second one will be for the positive ions arranged in rows. Third one will be for the delocalized electrons. And finally, for how this lattice is held together, it held by the electrostatic force of attraction. How can you get the 4 marks for this question? Question B, transition elements and elements of group 1 have some similar physical properties, like they can be hammered into shapes, they conduct electricity, and they can be stretched into wires. Name the term used to describe the ability of element to be hammered into shape. This ability is called malleability. The metal is malleable, it means it can be hammered into shape. Describe what happens to the particles in iron when it is hammered into a shape. When it is hammered, the layers of the positive ions, the layers of the particle slide over each other. Suggest why copper rather than other transition elements is used for wires which conduct electricity. Copper is used in electric wires because copper is good conductor of electricity, and it is unreactive, it resists oxidation, and it is also ductile. C. Transition elements are harder and stronger than group 1 elements. Describe 2 other physical properties of the transition element that are different from those of group 1. They have higher density than that of group 1, and of course they have higher melting point than metals of group 1. Question D. Chemical properties of some group 1 elements are shown in the table. Lithium, reaction with cold water and reaction with oxygen. It forms steadily effervescence with water and form colorless solution. Very slowly form an oxide layer when react with oxygen. Sodium, strong effervescence, it also form a colorless solution and slowly form an oxide layer. The color of the flame test in case of sodium, it's yellow. And third one, in case of potassium, it reacts with cold water very strongly and form very strong effervescence, form a colorless solution, and quickly form an oxide layer when react with oxygen. The flame test for potassium gives lilac color. This is the arrangement of group 1 element: lithium, sodium, potassium, rubidium, and cesium. We know that the reactivity increases as we go down in group 1, so rubidium is more reactive than potassium, and potassium is more reactive than sodium. So here we have strong effervescence. Then in case of potassium we have very strong effervescence. So we have to give here the answer which is more stronger than in case of potassium, because rubidium is more stronger, more reactive than potassium, so it will give very strong effervescence, very violent and explosive reaction, and very strong effervescence. And in case of reaction with oxygen, it will very quickly form an oxide layer with oxygen, and it also will form a colorless solution when react with cold water. So you have to add here for the table the flame test colors. We added for sodium, it's yellow, and for potassium, it's lilac. Then predict the reaction for rubidium with water and with oxygen. You have to write more stronger and more vigorous reaction than in case of potassium, because rubidium is more reactive than potassium. Then name the gas produced when group 1 element react with water, as represented here by this equation. When sodium reacts with water, it will form sodium hydroxide, which is the colorless liquid formed here, and the gas is hydrogen gas. Name the solution formed when potassium reacts with water. Similarly as in case of sodium, when potassium reacts with water, it will form potassium hydroxide. Then predict the pH of the colorless solution formed when potassium reacts with water. Potassium hydroxide is a strong alkali, so the pH will be high. They will accept any pH higher than 7, from 7 to 14. So I choose here 12 because potassium hydroxide is a strong alkali. Write a chemical equation for the reaction of sodium with oxygen. Sodium will react with oxygen to form sodium oxide. And this equation is for 2 marks. 1 mark will be for balancing the equation. Question E. Iron is a typical transition element. It's a catalyst used in Haber process. Write the equation for the reaction that occur in Haber process. Haber process is a reaction between nitrogen and hydrogen to form ammonia. Here again, this question is for 2 marks, so you have to balance the equation. 1 mark for correct formula of the gases and the product ammonia, and the second mark will be for balancing the equation. State the temperature and pressure used in Haber process, including units. The temperature is 450 degrees Celsius and the pressure is 200 atmospheric pressure. Then we'll go to question 6, the organic part. Ethanol belongs to homologous series called alcohol. Write the general formula for alcohol. The general formula is CnH2n plus 1 OH. Explain why ethanol can't be described as hydrocarbon. Hydrocarbons are compounds formed from carbon and hydrogen only, but ethanol also contains oxygen, so it is not hydrocarbon. It is not only made from hydrogen and carbon, it contains oxygen as well. Ethanol can be manufactured from different substances by reaction with steam or by fermentation. First one, give the formula of the substance which react with steam to form ethanol. It's ethene. Ethene react with steam to form ethanol in an reaction of water. Name a substance which will undergo fermentation to form ethanol. Glucose undergoes fermentation using yeast and it will form ethanol. Ethanol is a fuel. Write the chemical equation for the complete combustion of ethanol. When ethanol burns in the presence of oxygen, it will give carbon dioxide and water. And here again, you have to balance the equation. Question E. Ethene 1,2-diol has 2 alcohol function groups. 1 molecule of ethene 1,2-diol will react with 2 molecules of ethanoic acid to form molecule X. Ethene 1,2-diol is alcohol. It will react with ethanoic acid to form X. So X is an ester because ester form it when acid react with alcohol. He gave me here the molecular formula of this ester. It will be C6H10O4. And he won the empirical formula of X. The empirical formula is the simplest whole number ratio of the molecular formula. So here we will divide these numbers by 2. So it will be C3H5O4. Dividing the molecular formula by 2 to give the simplest whole number ratio C3H5O2. Then he wants you to draw the structure of the ester formed labeled X. Show all the atoms and all the bonds. Here the ester linkage will be from both sides. Here we will write it as the ethanoic acid. These are the 2 carbons of ethanoic acid, and here is the first ester linkage, and from the other side we have the 2 carbons of ethanoic acid, and here is the second ester linkage. If you count this number, the carbon atoms, number of carbon atoms, 1, 2, 3, 4, 5, 6, as we have here in the molecular formula, C6, and hydrogen will be 3 plus 2, 5, and 5 from this side, it will be 10, and 4 oxygen. This is the correct formula of the ester formed. Name other substance formed in this reaction. When alcohol react with acid to form ester, they remove water, 1 molecule of water for each ester linkage, so the other product formed is water. Question F. Each alcohol function group in ethane 1,2-diol react with acidified potassium manganate to form different organic compound. Acidified potassium manganate is an oxidizing agent, so it will oxidize the alcohol into carboxylic acid. So the functional group formed in compound Y will be carboxylic group or carboxylic acid. Here he wants me to draw the structure of this carboxylic acid, showing all atoms and all bonds. The 2 carbons in the ethane diol will be oxidized to form 2 carboxylic acid group. So the formula will be as shown here, 2 carboxylic acid and the acid known as oxalic acid. Here we come to the end of our exam. Please like the video and subscribe to the channel. Thank you for watching. Hope you all best of luck.